In a world of high-frequency trading, latency is everything. A single millisecond of advantage can mean a million or even a billion of dollars. That's why many firms turn to FPGA. It's fast, it's deterministic, and it delivers ultra-low latency than software alone can't match. But there's a problem. FPGA is hard. The learning curve is steep. You need digital design knowledge, HDL or Verilog coding, complex hardware tools, and development takes time. Hardware design is far more complex than software. Iterations are slower, debugging is harder, and traditional FPGA coding languages aren't exactly developer friendly. So, what if it didn't have to be that hard? What if FPGA development could be simple and fast and accessible even for engineers without deep hardware background? And that's why AAT exists. AAT is a complete FPGA trading framework designed specially for high-frequency trading. At the core of AAT is high-level synthesis. Instead of writing complex HDL or Verilog code, developers can describe trading logic in high-level software-like code and let the framework handle the hardware detail. New engineers can build FPGA logic faster, and experienced teams can focus on strategy, not low-level logic. Development cycle that once took months can now be completed in just weeks. With AAT, FPGA no longer feels like hardware. It feels like software but with hardware speed. And AAT doesn't just simplify development, it also introduces a clear step-by-step workflow. Step 1. Start in software. Develop and validate your trading algorithm using familiar tools and environments. No hardware involved. Step 2. Move into AAT. The algorithm still runs in software, but now it's connected to the FPGA framework, receiving real market data and interacting with the trading pipeline. This lets you test performance and behavior before converting anything into hardware. Step 3. Deploy to full hardware. With confidence, the same algorithm is synthesized into FPGA logic, delivering ultra-low latency in production trading environment. From software to hardware, in a controlled, seamless flow. Even with this simplified workflow, nothing is taken away. AAT is a complete trading framework built for production environments. Order book maker for fast, deterministic market views. Snapshot request for state synchronization. A/B arbitration for intelligent multi-feed decision making. Recovery for resilience in volatile markets. All fully integrated or FPGA accelerated. Simple to develop, powerful in production. Beyond the core framework, we also provide market-specific customization service. Different exchanges come with different protocols, data format, and trading rules. From feed handling and order entry to exchange-specific behavior and optimizations, allow you to deploy faster with confidence in real production environments. Now, that wraps up the framework overview. Let's see it in action. In this setup, we have an accelerated trading system powered by an FPGA X3522 card running AAT. Alongside it, a second PC acts as a market emulator, simulating exchange behavior and market responses. We connect the two systems using SFP plus AOC cable, a 10 gigabit Ethernet link between FPGA card and the market emulator. Once the network initialization is complete, we send a snapshot request to the market emulator. You can see the snapshot appear in the order book, confirming that the initialized market state has been synchronized. Next, we log into the order entry, preparing the system to send order to the market. Before we begin trading on live feed, let's briefly look at the algorithm used in this demo. The strategy is peg algorithm. Whenever the top of order book changes, the algorithm automatically sends the order with fixed price offset from the updated market price. This logic is implemented using simple C++ with the help of high-level synthesis, making hardware development feel very similar to software. Now, everything is ready. We replay the live market data from the market emulator into the trading system. On the left, you can see the market data tape visualizing real-time order book activity. On the right, the console tracks the market emulator order book state, which we will later compare against the trading system. As market data flow in, the order book on the trading system updates continuously. When the trading condition is met, an order is triggered and sent, with the corresponding price displayed in the console. At the end of demo, you can see that the order book state from live feed match the order book state inside the trading system. That concludes the demo. AAT delivers software simplicity with FPGA level performance for ultra-low latency trading. To learn more about AAT, request a demo, or discuss exchange-specific customization, contact us. And thank you for watching.